Okay, today we are going to the lab sessions. So please go to this Padlet link, the CSA2. We uploaded this link into the Spectrum. You can go and check. So today we're going to learn the addressing mode. The first one we're going to learn is indirect addressing. This is the same as the one we learned in the lectures, in the instructions architectures. For in here we're going to look into the addressing mode of x86 architectures. So you just copy this code into the project 32 folder, project 32 file in the Visual Studio. Okay, you just copy it into the project 32 file. Then remember, every time you copy, you must remain the include and also these last three lines. You just paste the thing in the middle of it. After that, you just build the code. You should get the successful message. So after that, we will go into the debug mode. We go to debug and we start to do the debugging. So then let's look into how this addressing mode going to happen. The first three lines, they are basically clear your EAX, EBX, and ECX. Okay, so quickly step through these three. Then all of the EAX, EBX, and ECX become 0. So now the next line is the offset of variable 32. Offset means we are getting the address locations of these variables. Okay, instead of getting the data, we are getting the address locations. So let's step through this code. Then refer to your ESI register here. So let's see what happened to ESI. So when I step through, they are not bringing the 1, 2, 3, 4, 5, 6, 7, 8, but they are bringing in the 46,000, the address locations of this variable, right? So they are bringing in the locations numbers into the ESI. Okay. Then the next one is come to the command of indirect addressing mode. Okay, so I'm moving something into the AX. So please look into the AX, the last 4 digits of the EAX. Okay, so when I step through, I'm bringing 5, 6, 7, 8. I'm bringing in the content pointed by ESI values. ESI is this 46,000, but they are not bringing in the 46,000 into your AX. They are bringing in the values pointed by these register numbers. So this is considered as a register indirect addressing mode. I'm using a register to show the address locations. Then the processors will go to these locations to get the exact data I want. So basically this is a register indirect addressing mode. So that's why they will go to the locations to bring in 5, 6, 7, 8 and put it into here. Then let's see the next one. If I bring into EBX, so this is your EBX. When I bring in, they'll bring in the whole thing 1 until 8 into your EBX. Okay, then the last one is your CH. CH is these two. Okay, so when I bring in the run the code, they are actually bringing in the 7, 8, the last byte into your CH. Okay, so if you have the bracket together with the register, you're not bringing in the content of the register. You're bringing in the content pointed by the address numbers in the register. Okay, your ESI is having the number 46,000. If you have the bracket, they will go to this 46,000 memory locations to get the data you want. Okay, so if you don't have the bracket, so let's say if you delete the bracket here, Then we debug it again. So quickly step through the first few steps. Okay, so if you run the this command without the bracket, okay, the ESI without bracket, let's see what happened to your EBX. Okay, your EBX initially now is a 0. So if I run this code, they are bringing in the content of ESI. Your ESI is 46,000, right? So they are bringing in 46,000 into your EBX. They are no longer bringing in the content pointed by the 46,000, right? So there's a big difference if you have the bracket and without the bracket. So if you have the bracket, mean the register actually a pointer point to a memory locations. If you don't have the bracket, the register is contain the operands, contain the values. Okay. So okay. So without bracket means this is a register addressing mode, right? Okay. So this is the indirect addressing mode for x86 architectures. Then you can go to the next one, which is there's one example you can try to go through. They're basically the same thing. You can using the ESI plus 1. You can using the ESI plus 1. Okay, you can using the ESI plus 1 to go to the next locations. Okay. Okay, so let's try this one. Copy this thing and put into your Visual Studio. So remember, just erase the part .data and .code. Then we debug the code. Start debugging. Step through, so means this one is just clear. The first one is clear the EAX. Then the second one do the same thing. They're using the offset to get the address locations of variables 8. Okay, the ESI will contain the address of variable 8. Then the next one, they are moving the content of ESI into AL. The byte PTR it just mentions that you're going to bring a byte from these locations, but with or without the byte PTR, I think it should be the same, because for this indirect mode, they will refer to the size of the locations, to the destination. Okay, so you can delete this line, you'll get the same result. So you can try. Let's say okay. So without it, they are just going to bring one byte from the locations pointed by ESI. So the location pointed by ESI is 46,000, which is this variable 8. So they are supposed to bring in the first byte, which is number 1 here. So means your AL will become 1 at the end if this code is run. So let's see, to AL is here. Okay. Yeah, so AL become 1, right? After we run the code. Then the next one, you can go to the next location by just simply add 1. So if I ESI plus 1, I will become 46,001. So the 46,001 basically they are go to the number 2 here. Okay, 3 is 46,002, 3, 4, 5, 6, 7, right? So you plus 1 means you go to the next locations. So the next location is pointing to a 2. So if you run the code, they will bring the number 2, right? Okay, so we go to the next one, the index operand. So you copy the code, do the same. Okay, so you copy the code into Visual Studio again, then we go into debug mode. Okay. The first one, clear the EAX. Then I bring 1 into ESI, so ESI become 1. So this is a variable 8 and 1 ESI values. So what happened if I bring this thing? So in the bracket means ESI minus 1, so ESI is 1 minus 1, so means 0. So basically your variable 8, you're bringing variable 8 into your AL. So let's try. So look at the AL, your EAX register, the AL. So what happened? Your AL become 1. Okay, so means they are bringing in the variable 8. Yeah, so it's the same as a move, same as your move AL variable 8, right? You're just bringing in the variables into your AL. Then the next line is a variable 8 ESI, so let's see what happened. They're bringing the 2 into your AH. So this index operand is just like the displacement, where using memory locations and also the displacement, but this displacement you are using the register to have to give you the values of the displacement, right? You are using the register as the displacement value in here. Okay, so this is the index operand. Then we go to the next one. The next one, you can try the example of index operands. For index operand, you can also using the multiplications. Okay, in here they're using the ESI's times 4. So it is you can use multiply also, just using the same bracket. But you in the previous one you're using plus or minus. In here you're using the multiply. You can using multiply also. Okay, so for this one, the variable 32 is in terms of the words. So let's say if we change it to byte, you can try to do the coding. How are we going to yeah, in here the result you are storing the 4 into the 4. You are storing the 4 into your EAX at the end after this code. So if we change it to byte, you try to think how you're going to change the code so that you are going to store the number 4 also into your EAX. Okay. Then there's another indirect examples. I think we are not going to go through this one. So the last example is the indirect PTR. So let's copy this one into the project 32. Okay. So after copy here, go into the debug mode. So first you clear the EAX, then you bring the date value address, then you increment by PTR ESI. So means you're going to increase your ESI values here. So let's look into memory. Your ESI value is 1, 2, 3, 4, 5, 6, 7, 8. Right? So after I increase INC increase, it will become 1, 2, 3, 4, 5, 6, 7, 9. Right? So this is what happened if using the increase. But let's say if I delete the byte PTR and I try to run it again, then what's happened? So you see there's a instruction operands must have a size, right? In here, if we didn't define the size, they don't know what are the size of this ESI address is pointing to. So you must give them a size where this ESI want to point. Only they can run the operations. Remember before this, if it's a move AL, then you can just simply using the ESI, right? But for move EAX, yeah, AEX, you also can using the ESI. Then the size is given by the destinations AL, then which means this ESI is pointing to a byte. If it's EAX, then this ESI is pointing to a double word. But if this increment, there's only one operand, there's ESI only, you must give them a size, then only the operation can be run. You can either give them a byte PTR, then it will run, or even you give a word PTR also they can run. So means the ESI is pointing to a word. Okay, since the increment is increased by 1, so if even a byte of word, you will get the same result. Okay, so I think this should be the fields instruction addressing mode we have in the x86 addressing mode we are going to learn today. Then the next one we will look into the loop functions. Okay, let's look into the loop functions. Okay, let's copy the this loop example into your Visual Studio and debug it. So the first thing is using the address, the offset. I bring the address to EDI. So your EDI is holding the register values, address value. Then the next one is the length of. So the length of will bring into ECX. So the length of the variable 32 is equals to 5. The length of is calculate how many elements you have in your variable 32 array. Remember the length of. So we have 1, 2, 3, 4, 5 elements in your variable 32 array. So that's why ECX become 5. Then they bring in 0 to your EX. Then they start. So this L1 is a label, right? This is the label. Okay. Then the first one is the add EDI into EAX. So the same thing. This is the indirect addressing mode. So means they will bring in the values pointing by EDI. So EDI is 46,000, which is point to 1 here. So means they'll bring in the 1 and add into EAX. So EX is 0, so add 1 become 1, right? Then they will add your EDI with the type of a variable 32. So since we want to add up the arrays, so we need to increment by following the size of the variables. So this is a this is a D word. So means the type is equal to 4, so they will add EDI by 4. So we are pointing to the next one, your EDI will become 46,004. Right? Then only they loop back to L1 and loop back to L1, which is the add. So now I'm going to add the values pointing by 46,004, which is the EDI. EDI pointing to 46,004, so it should be number 2. Okay, remember how this thing works? Okay, so let's look into this one. Remember the the array here. So this is your array, yeah. The word. So let's say this is 46,000, right? In the example just now. So this is your 01. Then it's a D word here. So D word means they are equals to 4 byte. So every location is equals to 1 byte, 1, 6. So here should be 0, 0, 0, 0, 0, 0. Then only come to number 2, 0, 4. Right? So this is 6,000, 40. Yeah? Everything is 40. Okay? Then this is 40, 6,004. So that's why at the first thing, they are adding your EDI content, which is 46,000 here, into the EAX. Then they follow by add the EDI by the type of variable 32. So variable 32 is a D word, so they are adding 4 into your EDI. So now your EDI is contain these values. So basically pointing to the next values, right? So that's why you need to using the type to get the value you need to add so that you can reach to the next element. So let's say this is if we change this to a byte, then if you use a type, then you will add 1 into the EDI. So you are going to point to the next one is here. So if it's a byte, then you will get something like this one. So if it's a byte, it will be 01, 02, 03, 04. 6,000, 6,001, 6,002, 6,003, right? So this is how they set up the memory content. If you're using byte, it's this one. This is for byte. This is for the word. Okay. This is how they're going to happen. Okay. Then we go back to the our Visual Studio. So if you look into the Visual Studio, yeah, the second loop they will add the 2, right? Then you come 3, loop back to F1 again, right? So after you loop everything, they are adding up. So you can see every time you pass the loop, your ECX is reduced by 1. Yeah, forget to show you this thing. So let's say we start again. Okay, your ECX become 5. Then we go into the loop. So this is the first loop. So then they loop back. So now your ECX still is 5. So let's say I loop back again. Your ECX automatically reduced by 1. Okay, so when using the loop operations, the content in ECX will reduce by 1 by itself. Okay, so the loop functions will keep on looping if your ECX is not equal to 0. So the second time your ECX become 3, ECX become 2, ECX become 1, then ECX become 0. So means you are looping out from the loop. Okay, so if you're using loop, your ECX will automatically reduce by 1, then until it's 0, they are not going to be looped again. Okay, so this is the function of loop together with the ECX. So loop is working together with ECX. So that's why they're using the length of the variable. You want to add up the array. So only you just need to know how many times you need to loop in order for you to add up all the things in the array. Okay. So the next one we'll look into the jump. Before we go to the jump, this is the answers for this question. Remember just now they're asking if I change the thing to byte, what is the coding to get the same result as in this one. Okay, so this will be the answers. In here they're using the type here so that only you know how many elements in the jumps. Okay, so they're using, you want to go to the third elements after the number one, 3 more elements, so that's why using 3 times the types. So they were using the type of variable 32 will be equals to 1, so at the end the ESI will equals to 3, so then you are adding 3 into your pointer, then you'll go to get the 4 from here. Okay, so the last one, let's look into the jump instructions. So the jump instruction is so let's look into the example. Copy this one into your Visual 32. So let's debug in Visual 32. Okay, so let's say debug in Visual 32. The first line is the same thing, the offset, the length of, then I set my EX to 0, then I start into the loops. Okay, instead of using the loop just now, I'm using another one, is called jump, right? Just now I'm using the loops, it depends on the ECX. So now I'm using another functions called jump without using the loop. So after I add up the bring in the first values, I will subtract my ECX by 1. So in here you need to subtract ECX by yourself if you didn't use a loop. So I subtract it, become 4, your ECX become 4 now. Okay, ECX become 4, then I will check whether I need to jump to L1 or not. So in this one is J and Z means they will jump if not 0. If the result here is not a 0, then I will jump to this label L1. So since now after I minus ECX minus by 1 is the result is 4, so it's not equal to 0, so I will jump to L1. So they will loop to L1, then they do the operation again, then they subtract ECX by 1 again, then they check again whether the result of these subtractions is of the previous operation is equal to 0 or not. Since it's 3, it's still not equal to 0, then I will loop again. Okay, then 2, I will check, it's not 0, jump. Oh, sorry. Start again. Quickly go through. Okay, 2, I will jump again. 1, I will still jump again because it's still not 0. Then here it will become 0, so I will check if it's not equal to 0, I will jump to L1. But since it's 0 now, so I will not jump. I will not jump to L1. So I will just out of the loop. I will go to the next line. Okay, so this and the loop, they're giving you the same result. So the jump, there's a lot of condition you can use. So if you refer to the one in okay, so let's look into the jump. Yeah, so you can see there's a lot of jump function here. So this is the jump with condition. Okay, so you can check what are the jump conditions. Jump if overflow, jump if not overflow, jump if not sign, jump if sign, then jump is not equal, jump is not. Okay, so this is all the condition you can use. Okay, jump with condition. Okay, so all this jump basically they depends on the status flag. So if your status flag equals 1 means there is overflow, if the status flag equals to 0 means there is no overflow. Okay, so that depends on the status flags in your status register. Remember we discussed about the status register. So there's all the bits in the status register here. Okay, so just now the one if jump if J and Z, right? Yeah, it's one. Jump if not 0. So both of these are the same. Jump if not 0, jump if not equal. They're the same. They are checking the 0 status flag. Okay. So this is how is the condition for the jump. Okay, so I think that's all for these sections. The rest we'll discuss in the next sessions.